This is Server Talk with Alexi and Mike, helping demystifying computing so you can make the best decisions in your business.
All right, welcome back to Server Talk, episode 2. I'm here with my main man, my good friend, and server expert, Alexi. Alexi, how's it going?
Pretty good.
All right, so today we're going to be talking about GPUs and the differences between GPUs and CPUs. And Alexi, take it away.
All right. So everyone knows what a CPU is. It's
Really? What's a CPU?
Well, the CPU is the processor inside of a computer. It's the thing that does the calculations. The big difference between a CPU and a GPU is that CPU has few cores that are really, really fast. So people are typically familiar with like dual core or quad core.
Okay.
And they usually are familiar with gigahertz, the letter gigahertz. And right now I think everyone's like 2 gigahertz, 3 gigahertz. And so the faster the gigahertz, the faster the CPU. The more cores, the faster the CPU is overall.
Mm-hmm.
Well, GPU is very similar to CPU, does calculations, but instead of having a few very fast cores, it has several million, thousands, I don't recall exactly, but they're very small and they're not as fast. And where the difference is, it's parallel processing. So in a CPU, you have serial processing, where an application one at a time, you just do it really quickly. In parallel processing, you do 10 tasks at the same time.
Okay, so slow down there. I mean, for the less technical people out there like myself, there is a lot of information condensed in that 1 second. So let's talk about serial versus parallel processing. And let me see if I understand this correctly. So in serial processing, let's say you have a 3-step process, and step 2 cannot resume until step 1 is finished. And then step 3 cannot start until step 2 is finished. But in parallel processing, you could do all 3 steps simultaneously.
That's correct.
All right, so it's working, and it's kind of slower. The initial speed is slower, but it's able to process multiple steps at the same time. So that's the core advantage.
Yep.
All right, cool. So what are the circumstances? I'm buying a server. When do I want to get a GPU? When do I want to get a CPU?
The CPU are still required. All systems are going to have a CPU, but the way your application is going to be written is it going to be able to handle the GPUs and be able to give the tasks out in that parallel processing kind of way. If you're buying a GPU, you're going to know it. That's really the first thing, because typically your application is written to handle GPUs. You know what it is. But
So there's even a difference in the software side?
Definitely.
Okay.
So that's probably the biggest difference, just because the software is what gives the command to do the task. So if you're giving serial format for the processor, well, that the application is going to give it one at a time. If you're doing it in a parallel processing for the GPU, you're going to throw them all at once. The application is going to give that task, so it's the application that's going to do it.
Okay. So just to clarify, the GPU, the software actually talks specifically with the GPU, is that correct? And
in simple terms.
In simple terms, right. So it accesses it and it has a process.
That's correct.
Thanks. Okay. Do all servers have a GPU?
No.
No.
All servers have a CPU, but not all servers have a GPU.
So which servers do have a GPU and which servers don't?
GPUs are pretty specific. By default, servers don't come with GPUs. They're an additional component that you can order. CPUs are required, 100%. They won't work without a CPU. That being said, not all servers can actually support GPUs, because GPUs consume a lot of power. So you need to make sure, again, your power supply can handle it. With power, you get a lot of heat being produced. You need to make sure that you have a lot of cooling to cool those.
Okay.
So, and then the last environment that's really important is how is the actual slot. Do you have a slot where you can populate this GPU in? Where a CPU has a dedicated CPU socket, a GPU goes into a normal slot, and you just need to make sure you have that slot.
I got you. So it's an interchangeable, modular type of structure inside of a server.
Yeah. What makes it pretty interesting is, though, in data centers and servers, everyone is trying to condense the space. And the smaller space you get, again, you have more power, and you got to cool all these systems. Right now, I think in a 1U form factor, you can put about 4 of these GPUs, which each GPU consumes about 300 watts. It's a lot of cooling that needs to go into one of these boxes.
I gotcha. So let's bring this more into real terms, right? I am a data center, and I'm ordering a bunch of servers from ICC. So do I want them with GPU or not?
Well, I'm going to ask you, what are you doing?
All right, so let's play this out then. So
sure.
Well, what am I doing? I'm a web hosting company.
No, you don't need it.
You don't need it. Why not?
Well, they're not doing any calculations. I want to rephrase that a little bit. I would ask, what kind of processing are you doing? Typical web hosters do not do any heavy calculations or any heavy processing or parallel processing, to be specific.
Okay.
And as a result, they don't really need GPU. Now, you might have specific type of hosters, such as high performance computing hosters, HPC hosters, that will need GPUs, that will benefit from it. Their applications are written to be in parallel.
Okay.
It really just depends on the application and what you're trying to do. If you want to really dive into it, I'll discuss the different industries and applications that can really benefit. Because it's still pretty niche, it's still pretty early, even though it's been around for a while, it's still pretty early.
Okay, so, I mean, can you give me like a brief overview, a brief history of how long GPUs have been around?
Well, if we're going that far, GPU, you should ask the question, what's the difference between a graphics card and a GPU?
That's kind of actually what I thought a GPU was. I thought it was a graphics processing unit. But
you're pretty close, actually. But graphics, so you have a graphics card in your computer and so on. And back in the day, everyone had their own individual card that did graphics. Well, nowadays, they're all built into the processor, the motherboard, or so on. And we have all this development that went into developing powerful graphics cards. And aside from specific people, not a lot of use is going out of those graphics cards. So they took those graphics cards and said, what can we do with them? And they made them into powerful processing units for specific applications. And really, they don't even have a video out. They don't produce any video. They produce a calculation, a number.
Okay.
So throw a whole bunch of data at it. It's going to crunch up your number. Crunch something up and give you a number back. To give you some ideas of where it can be used is, again, this is HPC. A lot of these cards you're going to see in HPC. You're going to see them in pharmaceuticals. So a lot of those guys need to do a lot of research. They're doing a lot of research and doing the calculations, and they're coming out with specific data. Oil and gas. They have all the research that where's oil. They're researching all that. Our project of where the stars or how the stars are in dark energy and so on.
Oh, right. Remember in episode 1 we discussed calculations for a very advanced telescope that's calculating the coordinates of every celestial body out there.
Yep.
And I'm assuming that they use a lot of GPUs.
Exactly.
Okay.
So that's somewhere where GPUs would be used at. So again, it's a pretty specific environment. They're pretty new. GPU graphics cards themselves.
Like in the modern iteration is new. The concept has been around for a while, but the
correct terminology would be GPGPU, which is, I don't remember. But it basically says using a GPU card for computational purposes.
Okay, I gotcha. All right, who makes GPUs?
There's a few companies. Most of them are going to be the same ones that are developing your video cards.
I would imagine Intel has a big stake in the game.
Surprisingly, not really. The two big companies are NVIDIA and ATI.
Okay, so they're the graphics companies.
Exactly.
They make the graphics.
So it's a very similar card, but it's targeted for computational purposes. Okay. There are a few differences, and we can get into them in a little bit after we discuss who big players are. So we talked about NVIDIA. They make the graphics cards, and ATI. NVIDIA is probably the biggest player in this industry. They have a specific line targeted for this, and it's called the Tesla line. So they make this card. ATI also has one, but it's not as popular. And one of the big reasons is the tools you have to develop your software. So the code. So NVIDIA provides a lot better tools to develop the applications and easier to use. As a result, you have a lot more people going out there using NVIDIA, developing in their languages and so on. So you mentioned Intel. Intel is about to or just released their version of this. They're about
the very first one.
Very first
After
one.
all these years in the processing game.
After all these years.
Yeah. All right.
It's taken them several years actually, but they first called it Knight's Ferry.
Not a very computational term. It sounds like something from like Lord of the Rings or something.
Well,
World of Warcraft.
They ended up sticking to the name Intel Xeon 5.
That sounds more like an Intel product. Something I'd put inside a computer, not something I'd like sprinkle in my daughter's drink or something. I don't know.
Yeah.
Knight's Fairy Dust or whatever. Okay, fine.
Yeah. So Intel Xeon 5. They just released it. They're still working on different versions of it. Not yet as competitive as NVIDIA. But what makes it a little bit more interesting is the tools that people have used to write code for their processor, now they can use similar tools or the same tools to write the code for this Intel GPU, which means they don't have to go and rewrite their code.
Okay.
And one of the big reasons why GPUs haven't really taken off completely, first of all, cost, and second of all, is people need to rewrite their code to use it. You got parallel processing versus serial processing.
I guess.
Well, if you don't have to rewrite your code, well, now you can just stick it in, maybe do a few minor changes, and there you go.
All right. Well, that's all over my head. I don't really know what that is exactly, and I'm sure that the listeners of this podcast and this video probably, well, actually, we don't know. Write to us. Tell us whether you know what we're talking about or not, or what Alexi's talking about. We'd love to hear from you because we want to know exactly what you guys want, what you want to hear about. You want a basic overview, or do you want detailed, very, very detailed and technical things? We'll provide you with exactly what you want.
It's not that technical.
It's not. Well, for me, not being in this industry, just being the guy that has a million questions.
A big question that I get, well, when coming to servers and GPUs is, well, why can't I just use a video card to do this?
Mm-hmm.
And you can. Again, the processors, they're probably identical processors. Actually, they are identical processors. And so you can.
Is it just a branding thing?
Branding's part of it.
They're literally graphics processors that they just call GPUs
and charge a lot more.
And charge a lot more? I mean, is that what's going on here, or what?
No, not really. Well, that's part of it. But the other part is that the big difference is you have more access to RAM on the actual card, so it can store more data on it, as well as you have ECC RAM. And what that means is the RAM has error correction. So if there's something wrong with the chip on the RAM, it's going to correct it. So how it affects you or any user and so on is, say for example, you're playing a video game, and you're using the video card that's meant for video applications, like gaming applications or so on, and you have something bad on your RAM. Well, you're going to miss a pixel.
Okay.
How is it going to affect you? Probably not a lot. Say, for example, in your video game, you're going to miss one little pixel.
Yeah,
you won't really care. You're not even going to probably turn off the game. Maybe eventually you'll notice.
Mm-hmm.
Well, in calculation, say, for example, you're missing a number.
Oh, yeah. one decimal point and you're way off. Especially if you project it out into space, like the trajectory of something light years away. I mean, you're off by like 1 billionth, and that amounts to,
Yeah,
just
remember
a ridiculous
NASA,
several light years in space. Yeah.
NASA counted instead of feet or instead of
right. Yeah, they messed up something with the conversion from the imperial system to the metric system, and then they ended up having to squander an entire Mars rover because of a mess up like that. Maybe they should have used a GPU.
Yeah.
Did they ever think about that? Maybe you should contact NASA.
Maybe it's not a bad idea.
Yeah,
that's very important. Good numbers is very important. So
all right, I got you. So I didn't actually know that. I thought that having weak sauce processing will just take longer. I didn't know you could actually, if there's enough processing going on, that you could actually miss numbers and have miscalculations because of this. So GPUs really are for extremely, not only for speed, but also for precision. So not to drop any, like you mentioned, pixels, or not to drop any numbers, not to make any kind of mistakes or...
It's comparing to video card GPUs.
Compared to video card GPUs.
Yes.
Yeah. Okay.
So processor's still not going to, like a normal CPU is still not going to make any mistakes or anything like that compared to video card GPUs.
Mm-hmm.
So, and then now there's also some companies out there that know, hey, we're going to have a certain percentage, if we're using video card GPUs, we know we're going to have a certain percentage of bad data, and they take that into consideration in their formulas and so on.
Mm-hmm.
So we've seen that approach as well. That approach is becoming less and less common just because data is harder to reproduce and it becomes more expensive to reproduce.
All right. Do you have anything to add as far as applications? Like, other than giant data centers, who else would be interested in including GPUs in their servers?
So what we see a lot of times is professors using them as in a workstation by their desk, using, again, calculations, some kind of application to do some calculations, statistical calculations, things like that. Maybe they're not capturing a whole bunch of data like space, but small calculations, but they still need to do it, calculate it fast. By a desk-side computer, that happens as well. We see that.
All right. Anything else? I mean, if I'm a prospective GPU buyer, if I'm considering upgrading my server, my order, to a GPU, what other things should I know before I take the plunge into the wide world of GPU?
Once again, if you're purchasing a GPU, you probably know that you're purchasing it. Most people are educated enough who are making the server purchase to know about them. If you're not, you have to consider the power consumption.
Okay.
Your application, which is probably going to be the biggest challenge, is your application capable of doing parallel processing versus serial processing? Mm-hmm. So we talked about power requirement, space requirement, heat requirement, and cost. So they do have a significant cost compared to the whole system.
Okay.
One other application where we see it being used or slowly developed into is CAD systems.
Right. Yeah, there's a lot of calculations.
Yeah, but that becomes actually pretty interesting just because you still have graphic-intensive portion of CAD because you're getting a rendering and you're seeing things displayed. So we're seeing a mixture between GPUs and high-end video cards for CAD applications to make it quicker so the rendering's faster, so the calculations are faster.
I gotcha. So that's kind of the burgeoning, the emerging field. Taking use of GPU is
at a local
CAD. So architecture, I'm assuming, and designers.
More at a local station, not at a data center or server farm.
I get you. All right. If you want to learn more about GPUs versus CPUs and etc., please read the accompanying article. There will be a link, or it'll be embedded into the article, so you'll be able to read and get more detailed information on it. I'm Mike Kaufman. This has been Alexi. Alexi, say goodbye.
Goodbye.
All right.
It was a pleasure.
It was a pleasure. And we'll be seeing you next time on Server Talk.
This has been Server Talk with Alexi and Mike. For more information on anything related to servers, please visit www.icc-usa.com.